By the way, I see two things.
Sorry?
I see two things.
Yeah, yes. I meant for it to do that. So that I can add page. Actually, oh no, why did it do that? Paper, can I swap this? Oh no. Sorry, wait a minute. Okay, let's go to question 4 first. Okay, let's take a look. So sketch the graph of y equals to ln 2x minus 3x more than 3/2. Insert in your sketch the additional graph required to obtain a graphical solution to the equation 2x equals to e power 2 minus x plus 3. Okay, so this is very simple. Basically, you first draw the sketch of the graph. How do you do that? You just need to remember the standard graph, y equal ln x. Two key things to take note of. First one is the vertical asymptote. It occurs at x equals to 0, which is the y-axis. Because ln of a 0 is not possible, right? So x equal to 0. What else? It also has an intercept over here. What's the coordinates?
1, 0.
1, 0. Okay. Sorry, wait. My highlighter is not working. Sorry, let me try again. Oh no. Sorry. Wait. Okay, yeah. Is the highlighter working now? It's not. I cannot split screen. Okay. Wait. Sorry, I didn't test this out. So sorry. Okay, so yeah, so we want to sketch this graph, right? What is the coordinates here for ln x?
1, 0.
1, 0. But that's in general for any logarithm base. Log a, as long as the a is more than 1. For fractional, it will actually look like an upside down logarithm. If a is if 0 less than a less than 1. Okay, good. So yeah, it will look like that one. Then what is it? So now we want to draw the graph of y equals to ln bracket 2x minus 3. So the key thing here to take note is you must first have the vertical asymptote. And that happens when the argument, ln of something, the inside is equal to 0. Yeah, so solving you get x equal 3/2. So that's why you should have a vertical asymptote at x equal 3/2. And that's why they also say x more than 3/2. Your graph will look something like this. But what's the intercept here now? Because it's the x-intercept, y equals 0. So we just need to sub y equal to 0. 0 equals ln 2x minus 3. So e power 0, or in other words, 2x minus 3 equals to 1. Solve for x, you get 1 plus 3, 4, 4 divided by 2. 2, 0. Okay, then they tell you that you want to use this to help you to solve the equation 2x equals e power 2 minus x plus 3. Okay, what do we have so far? We have ln 2x minus 3. Do you see a 2x? Do you see a 3? So 2x minus 3. Then, yep. So what does that mean? It means that you can draw a graph y1 here and another graph y2. Draw this graph and this graph. Find the intersection, you get your solution. So the answer is yes, draw y equals x minus 2. Okay, then you follow the same pattern for all the other questions. Okay. Yeah. Okay, hold on. Let me find the next question. The next question I want to go through is question 7. Let's take a look. I need to scroll back up. Okay, maybe I should have started a new worksheet. The scrolling is a bit slow. Okay, yeah, I'm not gonna do that. I'm just gonna start a new worksheet. Okay, question 7. Let's go. So this one, sketch the graph of y equals to ln x plus 3 for x more than -3. So same thing again. How do you think the graph look? What do you think the graph will look like?
Can you say again?
How does the graph look?
Okay, for y equals to ln x, asymptote is x equals 0.
X equals 0? No, wrong. X equals 0 is y-axis. When, okay, you see, asymptote is when there's a problem with the logarithm. When would there be a problem? When this x plus 3 here equals to 0, right? You cannot take the log of 0. So you should just set the x plus 3 equals to 0. So maybe you should remember it like this. ln, I like ln because it's easy to write, of happy face. The asymptote for the vertical asymptote, just set the happy face equal to 0. Then you solve for x. The simplest case is when this is just x itself, then you don't need to do anything. But here it's x plus 3, so you equate to 0, you solve, you get x equal -3. So -3 is your asymptote. So I'm just gonna move my y-axis over, so I have more space. X equals -3 here. Then your graph will always be more than that value. So it will look something like this. But we need to figure out at which point does it intersect the y-axis. So that's when we need to find the second guy, which is the y-intercept. So you sub x equals to 0. Then you'll get y equals to ln 0 plus 3, which is just ln 3. ln 3 is positive, so it's somewhere here, maybe, roughly. Then you just draw the curve. It must go approach the asymptote like this. I mean, like this, but then it will eventually move away. I'll take note, you do not curve downwards. You must keep on going upwards because the ln is an increasing function. It just increases slower and slower. You don't bend down, don't bend down. Okay, just keep increasing. Okay, so that is the graph. Then determine the equation of the additional straight line which would need to be drawn in order to obtain a graphical solution to e power x plus 2 equals x plus 3 power 4. So we need ln x plus 3. Do you see x plus 3 here?
Yeah.
You need ln. What do you do? Ln both sides. So ln both sides. What happens when you have a power 4? Bring down. You get 4 times ln x plus 3. ln of e, power bring down. You get x plus 2 times ln e, which is x plus 2 times 1, which is just x plus 2. Then you need ln plus 3 on its own. So you bring the 4 over, divide by 4. So 1/4 x plus 2 over 4. Of course, that's just half. Okay, so what do you think is the graph you need to draw? This guy. Oh, y equals 1/4 x plus half. Have you copied this down already? Copy down already? Okay, now I'm going to change to decimals to demonstrate to you what they mean by graphical solution. Hold on a second. Here, yeah. So we had the original graph y equals ln x plus 3. We are saying that we need to draw this extra graph 1/4 x plus half, mx plus c, mx plus c. Can see? So there's two intersections here. Can you see? -2, 0 and 7.347, 2.337. Can you see?
Yeah.
Can, huh? So actually this is a decimal value. It's actually, I believe it's 2.3333 all the way. But the solution will simply, to these two equations, will simply be the x coordinate of those 2 points of intersections. So it's -2, x equals -2, or x equals 7.347. Okay, but that would be equivalent to, if I just hide the graph, to the original equation that we were trying to solve. Like if you have y equals e power x plus 2, and then the other on the left hand side, then the right hand side is y equals x plus 3 power 4. This is how the two graphs will look. Then if you find a point of intersection between them, that's not right. Hold on a second. Let me think. That's not right. The solution is different. Sorry, let me double check again the first two graphs. Yeah, that looks correct. Then you have two intersections here and here, -2 and 7.347. For the other two graphs, they were obtained from the original equation. E power, sorry, the power is x plus 2. Okay, the plus 2, I wrote it in the wrong place, sorry. Now that makes more sense. And the other guy will be x plus 3 power 4, which is this purple guy. You get these two solutions. That's still not correct. That's a bit odd. I didn't think about the domain issue. Okay, I'll need to get back to you on this. But basically, supposedly, the solution to this guy, e power x plus 2, x plus 2, the plus has to be on the numerator, on the exponent. And then you subtract away the x plus 3 to the power of 4, and then you equate it to 0. You should get different solutions. Maybe instead of equal to 0, I'll just draw the graph y equals. If you find its roots, these guys, can you see? Those will be the solutions. Okay, this is the graph of the left-hand side minus the right-hand side. If you find the solution, the roots of this solution, it means you're equating this y equal to 0. Then you solve for x. And solving for x from the graph, you can tell it's these three values: -3.66, -2, 7.347. But because the if you look at the question, the original question 7, they mentioned that you want to sketch the graph of whatever for x more than -3, which means that we're only concerned with solutions that are more than -3, which means we need to reject the -3.66. Gone. This guy is not more than -3. So that's why there's only these two solutions, which were found from drawing the two graphs here. Can you see?
Mm.
The x coordinate -2 and 7.347. Yeah. So that's the graphical solution part. Okay. Back to the iPad screen. Okay, question 7. Done. Let's look at the next question. Question 11. Okay, for question 11, you sketch the graph of y equals ln x minus 2 for x more than 2. Okay, so again, when you want to sketch a ln graph, what are 2 things you look out for?
You equate x minus 2 to 0.
Yep, correct. So blah, 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 x minus 2 equal to 0, therefore x equals to 2. That's your vertical asymptote. Asymptote. What's the second thing to look out for?
Your y-intercept sub x equals 0.
Yeah. So you get y equals to ln 0 minus 2, which is ln of -2.
Undefined.
Undefined. Why?
You cannot log negative number.
Okay, but yeah, so this is undefined, which means that graphically, what does it mean? There is no y-intercept. Right? Why? Why would there be no y-intercept? Then how to draw the graph?
It doesn't.
No y-intercept, then there must be an alternative. Maybe there's a x-intercept. Yeah, it doesn't intersect the y-axis. So sub y equals 0. Then you get 0 equals, oh, actually maybe 3 things. Sorry, 3 things to look out for. Just find intercepts and vertical asymptote. So this one will be ln x minus 2. Solving, you get x minus 2 equals to e power 0, which is 1. Do you get how I got a 1?
Anything to the power of 0 is 1.
Yeah, correct. In this case, it's e. Ln is log base e. You bring the base e over, you get e power 0. Maybe I'll just write that down. Then you get x equals to 1 plus 2, which is 3. Okay, so you intersect at 3, 0, and you have a vertical asymptote x equals to 2. Then how does the graph look? Can you try sketching? On the, exactly, okay? Something like that. Just make sure you don't bend downwards. Just keep going upwards. Okay, then this is y equal ln x minus 2 for x more than 2. So now you want to draw a graph, additional graph, so that you can solve this equation. How? What's the pattern?
You want ln x minus 2. So ln both sides.
Yeah, exactly. So ln on the left, ln on the right. Then you end up with a sum. So ln e power 2x plus ln bracket x minus 2 equals to ln e power 3. Bring down the 3, you get 3 times ln e, which is 3 times 1, which is just 3. Likewise, over here, 2x can bring down, you get 2x times ln of e. ln of e is just 1, so 2x times 1. That's just 2x plus ln x minus 2. Who do you want as a subject?
ln x minus 2.
Exactly. So leave this alone. The plus 2x bring over become minus 2x. So you're left with minus 2x plus 3, right?
Draw y equals to minus 2x plus 3.
Yeah. So maybe we can do a quick sketch. It will be something like if x equals to 3, y will be equals to minus 2 times 3 plus 3, which is minus 6 plus 3 minus 3. So that means it's somewhere here. And there's a y-intercept of 3, so somewhere here. And the graph will look something like this. Right, this is the sketch of y equal minus 2x plus 3. This is going beyond the question already. Then finding the intersection, where is it? It's over here. So you're expecting your solution to be something that's in between 2 and 3. Oh, the solution to this equation is in between 2 and 3. Agree? Now let me show you the exact solution. So remove all the graph. What was our two graphs again? Y equals ln bracket x minus 2 close bracket, and y equals, what's the other guy that they asked, that we found out? Minus 2x plus 3. Okay, can see? And maybe I can draw in x equals 2 intercept, and I think I can change it so it looks like broken line. You can play around with decimals. I think it would be quite interesting, quite useful for learning as well. Can see? Yeah, so the answer is 2.232. But yeah, that's not the point of the question. The point is to know that you can use software to help you to find the solution by simply drawing this extra line. Don't need to, you can use software to find the solution for you, but you need to know what to put inside the graphing calculator.
Okay.
Yeah, so that's 11. Let's move on to the next one. What is it? Question 15, careless. Okay, let me see your working out. Question 15. Question 15. Something was wrong. Over here. 2x multiplied by 2 power x plus 1 is?
Wait.
This is question 15.
Wait. Hold up. 2x 2 to the power of x times 2x. Oh, won't it be like x squared plus x? Wait.
What happens when you have same base, different power?
Oh, you just add 2x plus 1.
Yeah, exactly. Not plus x. So I'll leave that to you on the rest of the working. Just a careless mistake. Should be a 1, not x. Okay? Can
Okay.
Yeah, it's just a quadratic equation.
Well, then what do you do after it?
It's just a quadratic equation. But you can do a bit of algebra. You see, if this is 1, right? 2 power 2x plus 1. Where have I seen it before? Oh, over here.
Also cancel.
Yeah, but this one cannot cancel because it's 2 power x plus 2. It's not the same as 2 power x. So you can do the rest already. I'm not going to go through. You can do
sub q equals 2x.
I guess you can do that, yeah.
Then quadratic, then okay.
This one actually no quadratic lah. A lot simpler. There's no power, there's no 2x here. It's just a single x. So there's no square. There's no square.
Okay.
It's just a linear equation. Yeah. Power 1. Even easier. Okay, Ken. Question 15 done. Moving on. What's the next question you got wrong? 19. Let's take a look at 19. What is 19? Oh, sketch the graph. Okay. Let me just copy this. Question 19. Paste it here. Then we can continue. Okay, sketch the graph of y equal ln x 2x minus 1. So first step. Okay, three things. First one. Y in the
x equals to half.
Yes. Equate the 2x minus 1 to 0, then you solve for x, you get a half. Oh, you're writing something? Sorry.
No.
Okay. Then yeah, so you got x equal to half is your asymptote somewhere here. Then the second thing, Maybe x-intercept.
Sub x equals 0. I mean sub y equals 0.
Oh, yeah. Then later we will do the other one. So 0 equal ln 2x minus 1. Ln is just log base e. So log base e. What happens when you have a base? Bring over e power 0, which is just 1. So it's equal to 2x minus 1. Solving for x, we get 2x equal 1 plus 1, which is 2, x equal to 1. So we get a 1, 0 somewhere here. Actually, by now you can draw the graph already, right? Yeah, it's just like this. Oh, okay. Then in that case, definitely there is no y-intercept, right? No y-intercept, then we don't need to bother finding it. You'll just get an undefined. You'll just get a ln of a negative number. Okay, now let's take a look at the equation we're trying to solve. 2x minus 1 power 2 e power x minus 2 equals to 1. How?
Ln
both sides.
Right.
Both sides, right? Exactly. So it's just ln on both sides. What's ln of 1?
Ln of 1 is 0.
0. Okay, good. Then what's a ln of a product? You can split it up as a sum. But wait, this one got power 2, bring down in front. Plus ln of e power x minus 2. But the x minus 2 can bring down. Then what are you left with? X minus 2 multiplied by the ln of e. After you bring the power.
Just 1.
It's just 1, so it's just x minus 2. What do we want as a subject?
Ln 2x minus 1.
So we can leave the 2 ln 2x minus 1 alone first, bring everything over. So we get minus x plus 2. Right, plus x minus 2 bring over, become minus x plus 2. Then after that, you divide by 2. So divide by 2 is negative half x plus 1. Y equal minus half x plus 1. Can? Draw this. Like maybe somewhere here. I don't know. I am guessing.
What's the question like after?
That's all. There's another question. Sorry. Hence state the number of solutions. Oh, 1. They're asking you to sketch the graph. Maybe just one. I'll just plot a few points. When x is equal to, draw a table of values. When x is equal to 0, you get a 1. When it's equal to 1, it's equal to half. Somewhere here and here. So the graph will look something like this. This is the 1, half. That was a 0, 1. This is the y equals to minus half x plus 1. So how many intersections do you see?
1.
1 only. So how many solutions?
1.
Exactly. Number of solutions is equal to number of intersection. 1. Okay? Can Can, then moving on. Okay, good. 19 done. Question 21, let's go. So question 21, let me double check. Where is my 21? What happened in 21? Careless mistake. Question 21, you got it until this step so far, it's fine. But when you have a fraction, I think what you are doing is you multiply by 40, right? This one?
Yeah.
But on the right hand side, if you multiply by 40, you need to distribute into each fraction. 40 divided by 8 is a 5. So there's still a missing 5 here. 40 multiplied by over 5, you'll cancel off with the 5, you're left with an 8. So you're still missing a factor of 8. So error carried forward. I'm not gonna go through. Okay, just do your own correction. Can?
Okay.
Then I move on already. That's just a careless mistake. Next question is question 24. Let's see what happened. What is 24? 24. Oh, another sketching graph. By now I think you know how to solve. Do I need to go through? Or just finish. Okay, so first thing you find is particle asymptote. Set What equal to 0?
X plus 2.
Then you solve, you get x equal to -2. So your vertical asymptote is x equal to -2. So somewhere like this. Okay, then x more than -2. So your graph will appear on the left side or right side? More than, so it must be
X more than -2, right side.
right side. So something like this or like this or like this, many possibilities. Okay, so what else we should find to help us determine? Maybe find the y-intercept. So set x equal to 0. Then you get y equals to ln of 2. Positive value. Oh, positive value. Then your graph will just look something like this. Okay. Good. So now you got the equation y equal to 2x plus 1. Got the equation like this. And they ask you, by drawing a suitable straight line graph on the same diagram, show how the solutions, they use plural, to the equation blah 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 can be obtained. So what should you do?
Bring the x to the other side, then ln both sides.
Good. Yeah, so we get x plus 2, then we ln both sides. So we get ln x plus 2, ln e power 2x plus 1. So 2x plus 1. Right?
Y equals to 2x plus 1.
Yeah, exactly. Good. Y equals to 2x plus 1 is the graph. So why did they mention S here, plural? Because there are
more than one.
Yeah, so ln2 is around what value? Can you help me to check? ln2 is
ln2 is 0.693.
Okay, good. Let me modify my diagram. I need more space. So I need my y-axis a bit longer. Close enough. Okay, then my 2 is somewhere here, because 0.6 is like smaller than 2. So 2 should be above. Then we know that there's a y equal to 2x plus 1. Oh, sorry, I meant to put a 1. We know that there's a y equal to 2x plus 1, so it must have a y-intercept of 1. So it must cut here. Positive gradient, so it must be like this. You look at the graph. How can it be? You see, this looks almost like parallel and like they never touch. How can there be solutions? It's because my diagram not accurate. Here is 0.6, then here is 1. Not drawn to scale. Not drawn to scale.
Mm-hmm.
So that means that we should draw a more accurate version, which is maybe somewhere here. Then our graph, and at this point, I would like to redraw my ln graph because it looks very, very bad. There should actually be 2 intersections. Something like this. Can you see?
Okay.
Yeah. Then this one will be your ln2. That will be your 1. This graph is y equal L. Sorry, no. What was the equation? 2x plus 1. The other guy is y equals to ln x plus 2. 2 intersection. That's why they mentioned a s over there. Plural. 2 solutions. Look for the x. Okay, you can use software to help you to find. Okay, that is question 21 done already. Sorry, 24. Sorry. Let's move on to the next question. So 24 all the way to 30 never do. I don't know. Okay, let's do that. Question 25. What do we want? We want x as the subject. Okay, let's go. Y equals to 1 over a minus 10 power negative bx. What do we want as the subject again? X as the subject. Okay, so maybe I multiply on both sides. So y multiplied by a minus 10 to the power of negative bx equals to 1. Then distribute. So you get y times a minus y times 10 to the power of negative bx. Who do we want as a subject again?
X.
Which, how many terms do you see on the left-hand side?
2.
2 terms. Which one involves x, left or right?
Right.
So leave this alone. The other guy we don't want. Throw away. So we bring to the other side, we get minus YA. But there's a copy and paste negative sign in front of the 10 power whatever. So we have to slowly peel away the layers. We want to reach the X. It's like the yolk inside the egg. And you have to peel off layer by layer. Get rid of all the egg white. So what's the first layer you see? Negative. What do you do with negative? Throw over to the other side. So you get y times 10 power minus bx becomes minus 1 plus ya. What's the next layer you see? Y times y, right? Times y. So what's the opposite of times? It's divide, right? So that means it's 10 power negative bx, the right hand side, but you need to divide by y. What's the next layer you see?
Log.
10. Opposite of power is logarithm. Log gives you power. Yeah, so you just get the power negative bx by logging base 10. You throw the base 10 over to the other side. Throw over to the other side, layer by layer. Throw over, throw over, throw over, throw over. Okay, so now you have negative b times x. How do you solve for x?
Divide by minus b.
Exactly. Then I'll just put bracket like this, then divide by negative b, right? So it's 1 over negative b multiplied by LG whatever. Okay, that's how you get the answer. Just peel it layer by layer. Can? Okay, good. Okay, they got a minus 1 over y. They just simplified the fraction. Here maybe I can simplify a bit. It's just negative 1 over y plus ya over y. Anything to cancel? Yes, the y cancels off. You're left with just a single a plus negative 1 over y, or a minus 1 over y. You can rewrite it as a minus 1 over y. Not important. Can?
Good.
That is question 25 done. Let's move to the next question. Question 26. Solve the following equations 3SF. And let's do that together. So we got question 26, part A. 6 multiplied by 5 power 3x minus 2 equals to 3 power 2x minus 3. Let's see. Straight away, just ln. You see your x is trapped inside the power, right? The opposite of power is actually logarithm. So when you see power, just take log. Just take log. I prefer ln. My favorite logarithm is ln. I always use ln. I don't know why. No idea, just used to it. Doesn't matter what base you use. It's either ln or lg, so that you can use the calculator. Then it's a product, right? So split. Yes, exactly. And if you're faster, then you can bring down the 3x minus 2 straight away. So that means we'll have 3x minus 2 bracket times ln 5 equals to, same thing here, 2x minus 3 multiplied by our ln 3. Take note that ln 3 and ln 5 is just a number, right? So that's really just like if I give you like 7 plus 3x minus 2 times 9 equals to 2x minus 3 times 10. Can you solve for x in this case?
Yeah.
If you can solve for x, then that means over here, when we change the numbers from 7, 9, and 10 into ln 6, ln 5, and ln 3, it is equivalent. How? Bracket, got a number, multiply it.
Minus ln 6 both sides.
Can. Then maybe this guy should also bring over, because it involves the x. When we're solving for x, all the x should be on one side. So we'll also bring that over. Let me just modify this a bit. I get a minus. Okay. Then how? Cannot factorize. You have to, no choice, multiply. So ln 5 times 3x, ln 5 times minus 2. So 3 ln 5 times x minus 2 ln 5. minus away, ln 3 times 2, which is negative 2 ln 3, x. And then negative times positive is a positive 3 ln 3 equals minus ln 6. Can? So it's something times x, something times x. Then you have a bunch of numbers. When you want to solve for x, you should leave x alone. All the numbers should bring over to the other side. Okay, so negative ln 6, leave it alone. Sorry, let me modify this. Yeah, negative ln 6, leave alone. Then you're left with minus ln 6, but plus 2 ln 5, minus 3 ln 3. Then you're left with the guy that involves x, this one and that one. Okay, 3 ln 5 times of x, minus 2 ln 3 times of x. How many x are there altogether? Factor out the x and you will get the answer. So it's just 3 ln 5 minus 2 ln 3. Number of x. Can? Okay, good. You can do some logarithm rules to combine them together, but that's not important. Solve for x first and just use a calculator. So right hand side, copy and paste it, but then you divide by the coefficient of x, which is whatever is in between the square brackets. Copy and paste the whole thing, bring over. Can you see what's going on?
Yeah.
Okay, then just use a calculator. Blah blah blah. Whatever is the answer. Can? That is part A. Can then I move on already. No questions? Okay, good. Question B, let me copy the question. Okay, this one is testing you on your exponent rules. It's yeah, the first thing you should recognize is power 0 is what? Anything power 0 is 1. Then power 2 is 4.
4.
And also, by the way, when there's a plus, can you combine them together so it becomes 2 power 2 x plus 3 plus x plus 1? No, very good. So what you need to realize is this is really just a quadratic equation because of the 2x here.
Oh.
Right? It's the same as this, right? Mic test, can you hear me?
Yeah.
Okay, good. And then plus, yes, correct. 2 times 2 power x plus 1 equals 2 power x times 2 power 2 plus 4. Yeah, so you can just let, I don't know, what letter would you like? U, okay. Then, sorry, I'm gonna move. You get u squared times 2 cubed, which is 8, plus 2u plus 1 equals to u times 2 squared is 4 plus 4. Blah, blah, blah. Do I need to continue?
Use calculator.
Yes. Please do that. Yeah, all your previous working was fine. Okay, I don't go through already. Okay, moving on. You got the idea. It's the same thing. So 27. No attempt. Okay. Is it? Yeah, okay. Just go through the entire question 27. Oh wait, there's a part A. Sorry, I haven't marked yet. What's going on? Without using a calculator, solve the following equation. Okay, let me see. Haven't had the time to go through. Sorry. I mean to mark it. Okay, so half you bring back up, is it? Yeah, bring back up. Then you get 2 times half, which is 1. So it's just LGX. Then you have LG15 add on. So that means you just get 15 times x. Okay. Then over here you have a half LG. You bring it over, so minus half LG. But you bring the half back up into a power. Then the 1 leave alone on the right hand side. Can. So now you have a difference of LG, same base. So it just becomes a quotient. 15x on top, 1 minus 4x power half at the bottom. Then LG is log base 10. 10 bring over 10 power 1. Then you just get a 10. Okay, then now we want to solve for x. How? Whenever you have a half, you must remember it's the same as a square root. Square root, certs. We went through a many questions involving square roots, right? So continue. So we get 15x equals to 10 times square root 1 minus 4x. Do I need to continue?
Wait, then what I do after this?
Square root. What's the opposite of square root?
Oh no, as in like what I do after? Like I never do anything already.
Oh wait, sorry. Oh, I didn't see. Oh, sorry. Oh, that's the next page. Okay, so let me continue.
Oh wait, I
Let's
got
see
wrong
first.
answer.
Let me see what you did. Oh, you
I
can
got wrong
multiply in the 10. No. Cannot. 10 multiplied by square root of 1 minus 4x. You see, this square root, right? It's like a VIP pass. You need to have the correct invitation card, then you can get to enter inside. The 10 doesn't have the invitation. But what if I upgrade? Yes, if the 10 works very, very hard, he earned $100, $10 become $100, then he can gain an invitation card. Do you get what I'm saying?
Okay.
So the 10 becomes a square root of 100. So now that they both got the square root, they are the same social status, then they can combine together. 100 multiplied by 1 minus 4x. Basically, this is just exponent rules. When you have the same power, then you are allowed to multiply the base together. Okay? If they have different power, you cannot. You cannot times the 10 in. So, oh, sorry, this step is wrong. In particular, this step. Okay? I think that's what happened, unless I interpret wrongly. How come here also got 1 minus 4x? Okay, I don't know what you're doing. If you multiply by 1 minus 4x, that's really just power 1. Then if let me continue the procedure. If you actually multiply by 1 minus 4x on the left hand side, it means you also have to do the same on the right hand side. So it's 1 minus 4x multiplied by a 15x. Then 10 times square root 1 minus 4x multiplied by a 1 minus 4x. Let me just move it somewhere with more space. Here lah, Sorry, a bit messy. Can you see? Do you understand what I'm doing? I move over. So if you did that, right, what happens is over on the right hand side, you should notice that power half here, square root means power half, right? And here is a power 1. So if you combine together, what do you actually get? The same base 1 minus 4x. Now it's a multi-term. Yes, correct, 3 over 2. Okay, don't need to talk so much already. Same base 1 minus 4x, but take note that it has more than one term. This is very important, knowing that this is 3 over 2. You will need to know this later on when you're doing differentiation. Okay, fractional powers must get used to it. Hey, cannot. 10 is not 100. Okay, 10 here is not the same as 100. 100 put in an extra square root. Oh, what do you do? Oh, you square both sides, is it?
Yeah.
Oh, square both sides. Okay. Yes, correct. Okay, let's just solve it together, maybe I'll start on a new page because I need more space for this. Oh, actually here got blank space. Okay. So yeah, whenever you got square root, just remember the super long-winded practice you did. Square root both sides, So 10 square times square root square. Okay, 10 square is just 100. Then square root square is just 1 minus 4x. Then what do you get? 100 minus 400x. 225x squared. This is just a quadratic equation, right? Then just calculator. Yeah. A, C. But you need to reject some answers because here is 1 minus 4x. Make sure the square root inside is positive or 0. Okay. Can I leave it to you to do the rest? Oh. Okay, good. Then I will move on. This is question 27, part B done, I think. Oh no, that was question 27A only. How about part B? Do you try part? Oh, haven't. Okay, can. 27 part B, let's go. So, Okay, maybe I should start a new page. Hold on a second. Question 27 part B. So you have 6 log x3 base x plus log x base 9 equals to log x base 3. I think you remember the identity, right? Whenever you want to swap the base and the number, it's just 1 over. Right? So here we notice base x, base 9, base 3. Variable, you try not to make it a base. Try not to. So yeah, swap it around. 6 over log x base 3. And why is base 3 a good choice? Because here, what is 9? 9 is 3 square, right? So we can rewrite it as change of base. Log x base 3, log 9 base 3. 9 is 3 square, so this is just 2. Oh, yeah, good. So we get log x base 3 minus 2. Then now we can just let u equals to log x base 3. Then what do you get? 6 over u plus u over 2 equals to u minus 2. Then what can I do? I think I'll multiply by u on both sides. Huh? Sorry?
Quadratic.
Yeah, quadratic, exactly. It's just a quadratic. 6 plus u square over 2 equals to u square minus 2u. Then you just bring them all together. Maybe I times 2 throughout, so I can get rid of the fraction. So 12 plus u square equals to 2u square minus 4u. Then 2u square minus 4u. I bring over the u square, I bring over the 12 equals 0. So we get 1u square minus 4u minus 12 equals 0. Can I factorize this? Yes, minus 6 plus 2. Then you get u equals to negative 2 or u equals to 6. Yay, solve for u. Are we done?
Reject.
No, sub back in. Log x base 3 first. Right, we are solving for x, not u. Then do we really reject? Not really. We get 3 power negative 2, which is 1 over 9. Or x equals 3 power 6, which is, I need a calculator for this. 729. How? Okay. Do we reject? Let's take a look at the original question. I'll bring it down. Do we need to reject?
No.
Here we got log x base 3, so you expect our x to be positive. Both are positive. Here we got also the same thing. But here we got log 3 base x. What do we expect for our x? Also expect it to be positive only. So both satisfy, that's why we don't reject any of the answers. Or maybe another thing we could check is let x equals to 1 over 9. Then you sub. Check on the left, then check the left-hand side. So this one, I would probably use a change of base. Maybe LHS will be equal to 6 times ln3 over lnx. In this case, x is 1 over 9. Plus lnx is 1 over 9 divided by ln9. What do you get? Likewise for the right-hand side, x over 3, which is not x, but rather 1 over 9 minus away 2. Do we get the same value? Got negative 4 here. I also got a negative 4 equal. Do you trust my answer?
Yes.
Can yeah, so x equal 1 over 9 definitely works. Let's also do the same check for the other solution, x equals 729. So LHS, I'm just gonna basically you replace all the 1 over 9 with 729. So I'll just copy and paste, and then I replace 1 over 9 with 729. Type it in the calculator. Oh, -2. You get what I'm doing, right?
Mm.
Okay, I'm just replacing the 1/9 with 729. Okay, I also got a 4, so it's definitely equal. That means that x equals 729 and x equals 1/9 both are acceptable. Or. Should be or, not and. Okay, can. Bing, bing.
Mm-hmm.
Can, moving on. So this is question 27, part B done. What's the next question? Question 28. What is question 28? There is no question 28. Is there? I don't know. Oh, 28 onwards, all never do. Okay. Let's go back to the top. Question 28. Yeah, all never do. Okay, let's just do it together. So sketch the graph of y equals to ln 4 minus 3x. Insert additional graph to solve graphically the other equation. So where's my x in? Yes. X equals 3/4. Okay, good. What else? Maybe we can find our x-intercept. 0. Okay, 4 minus 1 is positive 3. Oh wait, negative 3x. Sorry, I saw wrongly. Okay. Correct. X equal to 1. My fault. 1, 0. This is 1, 0. Okay. Can? Then you just draw the curve. All right. Good. What else? Copy the equation first. Then you need to get ln 4 minus 3x. How? Wow, it's getting more and more complicated. But I hope you can see that there's a 4, there's a 3x. Here also got 4, here also got 3x. So you need to link them together. So maybe it will be nice if we just take ln on both sides. Same procedure. Ln would be a good choice because there's a power e here, like e power something. So ln, what do you get? Oh no, that's a plus. Then how? Can we split up a sum inside the logarithm?
No.
Cannot. Then how?
Oh.
Okay. Let's see. So here you got e power 2x at the bottom. What happens if you bring it on top?
Minus.
Okay. We need the 4 and the minus 3x side by side, right? What should we do?
Oh, minus this.
Yeah, exactly. So we get 4e power negative 3.
Factor
Negative 2.
this.
Yes, correct. Then you factor out.
Then
Equals to e.
divide by that.
Yep.
Y equals e divided by e minus
It's e power 1 here. So we can simplify a bit into e power 1
minus 2x.
Yeah, correct. Okay, but then you ln both sides, so we get ln 4 minus 3x equals to 1 minus 2x. Y equals 1 minus 2x. Okay, so moral of the story is you see a plus, then you log, not a very smart choice. Don't log a sum. You should log a product or you log a quotient. This is more productive. You can do something with it.
Okay.
Good. Next. Huh? What? Don't know. Okay, whatever. Let's move on to question 29. Let's take a look. Part A, express x equals whatever in the form y equals f of x, and hence sketch the graph of x equals to something, something. Okay, so this is basically asking you to make y the subject. Okay. In the form y equals something, make y the subject. Let me copy the question down first. Paste here. Okay, copy x equals 1 plus 2e power negative y over 2. So times 2 over, you get 2x equals 1 plus 2e power negative y. What else? The y is over here. It's attached to the 2e. So yeah, exactly. Then 2x minus 1. Divide by 2. Then ln. But you have an extra minus, so negative bring in. To bring it over to the other side. But negative 1 can bring up as a power, so you can flip the fraction. So you get ln of 2x minus 1 over 2 to the power of negative 1, which is ln of 2 over 2x minus 1. Okay? Then insert, then let's look at part B now. Insert on your graph an additional, okay, hold on. Let me move my answer up first. This is the answer to part A. Then for part B, they asked us to insert a sketch of the additional straight line needed to illustrate how a graphical solution of the equation 2 times e power 1 minus 2x plus 1 equals to 2x may be obtained. So we already got ln of 2 over 2x minus 1. Do you see 2x? Do you see a 1?
Yeah.
What do you think we should do? Minus 1. Here is plus 1.
Yep.
Bring over. So that means you get 2 times e power 1 minus 2x equals to 2x minus 1. Then after that, what else we want? We want 2 over 2x minus 1. So what should we do? Or maybe it's better if I left it in the original form, negative ln of 2x minus 1 over 2.
Divide by 2.
Divide by 2 first.
Ln both sides.
Then ln both sides, yes. Then we'll end up with ln of 2x minus 1 over 2 equals to ln of 2 cancel off, you're left with e power 1 minus 2x. Ln and e also cancel off, you're left with 1 minus 2x itself. Let's just do it step by step. So we get 1 minus 2x equals to ln 2x minus 1 over 2. Still not done yet because the original one has an extra minus sign. So we need to times negative 1 on both sides. So it's actually 2x minus 1 equals to negative ln 2x minus 1 over 2. The answer is 2x minus 1. Okay? Does that make sense? Okay. Draw y equals 2x minus 1. If once you get used to these type of questions, we are able to move on to the next topic. But well, still got the other worksheet I haven't marked yet. I haven't looked at yet. Okay, let's do this last question. For this worksheet, the diagram below shows the graph of y equals e power 2x minus e. Find the coordinates of A and B. So basically, you want to find the y-intercept and x-intercept. So for point A, it's the x-intercept. So you start what with 0?
Sub y equals 0.
Y equals to 0. Okay, good. So 0 equals e power 2x minus e. Solve for x.
Ln.
Bring over first, then you ln. So because here is a subtraction, you take ln, you can't really do anything. So ln, then you get 2x
X
equals
equal
2.
half.
Yeah. Good. How about v? Sub.
Sub x equals 0.
Okay, good. Then we get let me see. Y equals to e power 0 minus e. Anything power 0 is 1, 1 minus e. Answer. Okay. Yeah, so that's how you get the two coordinates there. Yeah, that's all for this paper. And give me a second. I need to go and download your second file. Okay, let me see. This second file, volume of a cuboid. Okay, let's resume. Okay, given this one is actually a recap already. It's not so much on logarithms. It's on surds as well as some other topics on exponents. Okay, let's take a look. So given the volume of a cuboid V cm cube with a square base of length L cm cube, find its height h in each question. So how? H arrow 12 plus square root 64, that's the volume. Then you divide by the length square. Correct. So square this length, what do you get? You get a square plus 2ab plus b square. That's okay. Good. Then after that, you simplify it as 20 and 6 plus 4 root 2. Okay. Good. Then you divide by 2 first. Good. That's a very smart choice. Because if you try to rationalize, but we are with 6 minus 4 root 2, your number will get very big. Okay, then you multiply by its conjugate. Okay, multiply the 10 in. Okay, it's a plus b, a minus b is a square minus b square. So 9 minus 2 root 2 square, which is 4 times 2, 8 divided by 1. That's your answer. Good. Next question is volume is 24 plus 2 root 9. Then the length is 1 plus root 3 square to get the area of the square base. You get this guy plus this guy plus this guy. Correct. And it's 4 plus 2 root 3. Cancel off common factor of 2. You get 15 over 2 plus root 3. Can. Then hold on a second. Let me think a bit. Square root 9. Right. Correct. Okay. Correct so far. Then you just multiply by conjugate. Okay. Then 30 minus 15 root 3 over 1. Yes. 30 minus 15 root 3. Good. Okay, question 2. Show that this part 1 is whatever is divisible by 31. So you factor out 5 power negative 1. Oops. Factor out of 5 power 1. Okay. Then you realize there's a common factor of 5 power 2 and you factor that out. You get 1/5 plus 1 plus 5. That's 31 over 5. So that means that you can rewrite it as 31 times something. So then therefore it's divisible by 31. Okay, good. Then part 2, show that blah blah is divisible by 81. 4 power 2n minus 2 plus 4 power 2n plus 1 plus 4 power 2n. Divisible by 81. 81. Okay, let's see our working. We write it as this is fine. This is fine. Leave it alone. Factor out the 4 power 2n. Get this, add together. Okay. 4 power negative 2 is 1 over 16. Okay, actually, you can just key in the calculator. 1 over 16 plus 4 plus 1 is 81 over 16. That's okay. So you realize that there's a factor of 81 already. So therefore, it is divisible by 81. Okay, good. Question 3. Find the value of the following. So you just use change of base. LG9 over LG2, LG8 over LG13, LG13 over LG3. Cancel off. Then LG8 is actually 2 cube. So you can bring down the power 3. Then the LG2 will cancel off. You're left with LG9 times 3 times LG3. But 9 is the same as 3 square. So it's 3 with a 2 in front. LG3 will cancel off. So you're left with 2 times 3, which is 6. Don't need to use calculator. You get what I'm saying? Okay, I can understand now.
Yeah.
Okay, good. Then how about 3.2? LOG 25 base 2, log 16 base 11, log 11 base 15. Again, it's change of base. Okay. Okay. This one is 5 squared. 25 is 5 squared, so 5 power 2, bring down the power 2. 16 is 2 power 4, so bring down the power 4, get 4 times LG2. And then you have LG11 over LG5. LG11 cancels off your 1. LG5 will be combined together with this LG16. But 16 has been rewritten as 4 log LG base 2. So you get this. You cancel off the LG2. Yes. You cancel off the LG5. Yes. Then you're left with 2 times 4, which is 8. Okay, good. Correct. Next, solve each of the following. LG equals to LG blah blah plus 1. Okay, so 1 is the same as LG10, so 10 times x plus 1, 10x plus 10. Okay, both got LG, drop the LG, get a quadratic. Bring the x over, bring the 10 over. You get minus x equals 0. Solve for x, you get 3 and negative 2. 3 times negative 2 is negative 6. Same, good. 3 plus negative 2 is positive 1. If I multiply by a negative 1, negative 1. Same coefficient as x. Okay, must be correct. This one you reject as LG x plus 1 will become undefined. Okay, good. Yes. Next. What is this? Let me see. Hold on a second. This is part 2. LG x squared minus 13x plus 26 equals to LG 3 minus x plus 1. Okay, so 1 is it's the same practice. Basically, I just changed the numbers. So 1 is the same as LG 10. Then, sorry, both got LG 3 minus x times 10. You get 30 minus 10x. Okay, that's fine. Both sides got LG, drop the LG. You're left with the left-hand side equal right-hand side argument. Good. Then bring the 10x over minus 10x over, you get plus 10x, which becomes minus 3x. Bring the 30 over, become minus 30, you get minus 4. Okay, then you get 4 and negative 1. Let me double check first. Yeah, correct. Okay, then this one have to reject because log 3 minus x will become negative. Correct, yes. If x is negative 1, this one is still safe. Because if you try to substitute into the argument x squared minus 13x plus 26, or the other argument 3 minus x, it will still be positive. Okay, good. Next one, part 3. Log of 3 base 2022 plus 5 times log e power x base 2022 equals to log 6 minus e power x base 2022. You should realize by now that the base 2022 is just for fun. It doesn't really matter. Can be any base you like. So 5 bring up, then get e power 5x. Okay, can. So now that you have 1 times log, 1 times log, 1 times log, you're safe. Addition of logs, just multiply 3 with the e power 5x. Then this one is just 6 minus e power x. Since both sides got the same log base, you can cancel them off. 3e power 5x equals to 6 minus e power x. Then you bring the minus e power x over, become plus. Plus 6 bring over, become minus. Correct, good. Then how do you solve this? Oh, I just realized that it's a 5x. Why is it a 5x? Shouldn't be a 5x. 5 a bit too difficult. Can I just change the question?
Okay.
Change to a 2. Change to a 2 instead of 5. Quadratic, yes. So we get 3u squared plus u minus 6 equals 0. Let u equals to e power x. So solving, you get what? You get u equals to negative 1.5906 or u equals to 1.2573. But u is actually what? E power x.
Reject the first one.
I have to reject because e power something must always be positive. E power x is more than 0. Okay, maybe I write the reason on top. E power x is more than 0 for all real values of x. Yeah, here negative is impossible. Okay, so your only answer will be e power x equals to 1.2573. Then you have to ln both sides. Therefore, x equals to ln of 1.2573. What would that be? Some value lah. Let's see what it is. 0.945 3SF. Okay, can. Then part 4, 5, 6. Let's see. So part 4, you have log 2 base 9,999. 2 times log e power x base 9999 equals to log base 999 of 2 minus 3 power 2 minus 3 times e power x. So here there's a 2, which is a problem. We have to bring it up first. Then you get ex power 2, which is e power 2x. Then you have 2 multiplied by this power, ex square. E power 2x. Then you get 2 times e x bracket square. Okay. Then right hand side, you also have a log base 999, but it's just 2 minus 3ex. So you just copy and paste. The log 999 appears on both sides, so you cancel them off already. You're left with this equation. It's fine. Then you just let u equal e power x, then you get 2u squared plus 3u minus 2. Yes. Minus 3 bring over become plus 2 bring over become minus. Okay. U equals to half or u equals negative 2. Half negative 2. Okay. E power x equal half, e power x equal negative 2, reject because the logarithm is undefined. Actually, more simply, e power x should be more than 0 all the time. Okay. E power x is more than 0 for all x. For all real values of x. More than 0. Here, negative not allowed. Reject is the correct reason. Okay, solving for x, you get ln half. Yes, negative ln 2. Okay. Next one, part 5. 27 times 3 power lgx equals 9 power 1 plus lgx minus 2. So what do? 27 is 3 cubed, then same base 3 different power, so you just add the power. Okay, then 9 is 3 square, so there's a 2 multiplied into it, then 2, you get 2 times 1, which is 2, plus 2 times lg. Okay, fine, good. Next, you both have the base 3, but different power, so you can just compare the power, they will be equal. So now that you have this equation, what do? You bring the 2 up, so you get x minus 2 bracket square, and then you have a 2 here, you have a 3 here. You bring the 2 over, become minus 2. 3 minus 2 becomes a 1. Then you have lgx, you bring over, so you get minus lgx. Okay, can? Yes, that's correct. Let me double check first. Yeah, okay. Then after that, you combine the logs because there's a difference. And the coefficient here is 1, 1. Then you just become a quotient. X minus 20 bracket square over x equals to 10. Hold on a second. Right, the LG you bring over. 10 power 1. Okay, correct. Times the x over, get 10x. Square this one, you get x squared minus 40x plus 400. Then bring the 10x over minus 10x equals 0. So you get minus 50x plus 400 equals 0. Can then solve, you get 40 and 10. Here you reject. Why? Because, yes, correct. The x minus 20 will become a negative 10, which will become undefined. Good. Your rejecting region is correct as well. Okay, so x equal 40 is the only solution. Next one, exact same question. Let's just check it. So 125 times 5 power lgx equals 25 power 1 plus lgx minus 60. 125 is 5 cubed. Same base 5 different power, add the power, you get 3 plus lgx, but the 5 disappear because you can just compare the powers. Okay, good. Here you got lgx minus 60 bracket square and lgx. Bring over, you get a minus, which becomes a division. So lgx minus 60 bracket square over x. Then the 2 bring over, it becomes a 1, so you get a 1. But 1 is the same as, but lg you bring over, it becomes a 10 power 1, which is just 10. Then you have a divide by x, so you bring over, become 10 times x. Correct. Yeah. Then you square both sides. I mean, you open up the square, you get x squared minus 120x plus 3600. Correct. Yes. Bring the 10x over, you get minus 10x. Okay. Then minus 120 minus 10 is minus 130 plus 3600. Okay. Solve, you get 90 and 40. Here you reject because x minus 60. Okay. Can. Good. Okay, question 5. Let's go. So part 1, solve ln 4x cubed over 3x plus 2 minus 2 ln x equal ln x minus 4. So how do you do it? Bring this over, you get plus 2 ln x. The 2 bring up become ln x squared. Because there's addition, coefficient 1, you can just multiply the powers. Sorry, multiply the arguments. X minus 4 times x squared. Get x cubed minus 4x squared. Maybe not such a good idea to multiply because x cubed is difficult to work with. Should just keep it as x squared times x minus 4. Later you compare, then you realize a lot of common factors can cancel off. What you did instead is you just compare them and then you just multiply the 3x plus 2 over. Can also. So far, so clear. Then you multiply out. Okay lah, can also. It works. It's just a bit more long-winded. Then you get minus 12x cubed, then 2x cubed minus 8x squared. Good. Here you got 3x power 4 minus 12x cubed plus 2x cubed. This becomes a minus 10x cubed. But wait, there's a 4. Bring over, minus 14. Minus 10 minus 4 is minus 14 x cubed. Then here you got minus 8x squared equals 0. So how did you do this?
You factor out the x first.
X squared, you mean? So you should get x equal to 0 from the x squared equal to 0, and then the other two solutions from the quadratic. Let me double check. 3 minus 14 minus 8. 5.18 negative 0.514. Yeah, okay. Good. But then you have to reject. Why? Because x minus 4. Okay. Good. So 5.18 is the only solution, or the 3SF version. Here you also reject because if you sub in, you also get a negative value, ln negative 4. So both reject. Only answer is 5.18133, whatever. Okay, good. Next, hence solve the equation ln 4 times e power 6x over 3 times e power 2x plus 2 minus 4x equals to ln e power 2x minus 4. You're basically substituting the x with a e power 2x. Yes, good. You identified that. Okay, then you just need to ln both sides and then divide by 2. Ln to get the e over, divide by 2 to get rid of the 2. Okay, let me double check your value. Okay, good. Can, then the next question is the same thing. Okay, ln x over 3x plus 11 plus log 4 base 99 over log e base 99 equals ln x minus 2. So this one is just change of base. You can simplify as ln 4. Yep, good. Then what happens? Because there's addition, you can just multiply. So 4 times x. Okay, then you have log on both sides, same base, so you can throw away. You're left with 4x over 3x plus 11 equals x minus 2. Denominator, bring over. So you get 3x plus 11 times x minus 2. Multiply out, you get 3x squared minus 6x plus 11x minus 22. Okay, minus x plus 11, and then you bring over the 4. So you get minus 10 plus 11, which is plus 1x. Okay, good. Solving, you get these two. Let me double check with a calculator. 3, 1, negative 22, you get 2.54, yes. Negative 2.879, okay. Then, yeah, good. You can round off to 3SF if you want to. Never mind, you're not going for exam, it's okay. Hence, solve the equation, blah, blah, blah. You should realize that the x got replaced with e power x. Yes, good. Okay, then you just need to ln both sides. Okay. Okay, maybe I should have assigned this homework earlier because it's quite simple, huh? Okay, this one using appropriate substitution. Okay, let me see. Yep. Times e power x on both sides. Then you get ex squared minus ex minus 6, correct? Substitute u equals, get u squared minus u minus 6, get 3, -2, sub the u back in, then solve for x, take ln on both sides. Okay, same thing here, sub back in the u with e power x, take ln of -2, this will be undefined. Maybe in the future you will learn something called complex numbers. Then this will make sense. For now, no lah. It's just undefined. Okay. Okay. Good. Carry on. I don't know if I'm talking to myself or not.
No.
Okay. Can next one, part 2, 2 times e power x equals to 3 times e power -x plus 2. Then we get this guy -2 minus away e power -x bring down. You get e power positive x, but at denominator. What you did is you bring it over, so both positive become negative. Okay, that's fine. Then after that, you sub in u with e power x. So you get 2u squared minus 2u minus 3. Okay, that's after you multiply by e power x. Yes, okay. Then you get a quadratic. Okay, it's the same thing again and again. I'm getting quite bored of this. Your method is perfectly fine. So far, there were no mistakes. But then you have to sub the u back with the substitution e power x. This one, then you take ln on both sides. The other guy, what's going on? X equal to oh, okay, right. Okay. Yeah, negative. You have to take the ln of a negative, which is undefined. Okay, so you ignore it. Then this one is just the value, is it? Let me double check with a calculator. 1.82287556. 0.6004. Yep, correct. Okay. 3SF is 0.600. Okay. And another substitution question. 3 power x plus 1 minus 3 power 3 minus x equals -24 minus 3 power x. So here I got plus 1 means it's 3 power 1 times 3 power x. Here I got minus x means you just bring it down. So 3 power 3 on top, 3 power x below. 3 power 3 simplify as 27. Good. Minus 3 power x bring over become plus. Minus 24 bring over become plus 24. Good. Then what happens? There's 3 copies of this guy. Sorry? Oh, do you say something?
No.
Oh, okay. Yeah, I got 3 copies of this. 1 copy of this altogether is 4 copies of the same guy. 4 times of 3 power x. Then over here, you got minus 27 over 3x. Fine. Plus 24 over there. Okay, good. Then after that, you multiply throughout by 3 power x, left and right. So you get 3 power x squared. Then this one is 24 times 3 power x. This one cancel off with the 3 power x. You're left with minus 27. Okay, good. Then after that, you substitute u with 3 power x, you get 4u squared plus 24u minus 27 equals 0. Okay, solving for u, it's again a quadratic equation. Just sub into calculator for 24 minus 27. What do you get? 0.968. Good. Negative 6.968. Good. Then you sub the u back with 3 power x. You get this guy and this guy. And then you just skip a step. You just take log base 3 of a negative number straight away, undefined, you reject it. Good. This one you have to log base 3, so you need to use a calculator, ln something over ln something. Ln the 0.9686 whatever over ln 3. Or you could do LOG as well, same thing. LOG means base 10. In case you didn't know. I'm sure you know that. Then you get this. Yeah, correct. 3SF. Good. 290. 3SF, you need extra 0 here. 1, 2, 3. Okay?
Okay.
Yeah. Then question 4, 2 power 1 plus x minus 2 power 1 minus x equals to 5 minus 2 power x. So you get 2 power 1 times 2 power x. Then you, oh, what did you do here? Oh, 2 power 1 minus x is 2 power 1 on top, then 2 power x below with a minus. You brought it over here. Then you bring the 5 over, become minus 5. Bring the minus 2 power x over, become plus 2 power x equals 0. Okay. Then what do you do? 2 copies of this 2 power x. 1 copy of this 2 power x becomes 3 copies. Hold on. Yes, become 3 copies. But then you multiply throughout by 2 power x because you see the denominator. So this becomes a square. The 5 becomes a 5 times 2 power x. The minus 2 is because when you multiply by 2 power x, it will cancel off. You're left with a minus 2. Good. Yes. Then after that, you get let u equals 2 power x. So we have 3 power x, we have 5 power x, we got all the power x. Just let u equals. By now, you are super familiar with quadratic equations already. So now this becomes 3u squared minus 5u minus 2 equals 0. Then solve for u using our calculator. I can see the handwriting progressively turning into a V.
Yeah.
2 and negative 1/3. Okay. Yeah, you get the idea, huh? Yeah, it's just log again. It's undefined. It's undefined because it's negative. Then just here a special case 2 power x equal 2 power 1. You just have to compare the power. Okay, can let's check the next one. Is it okay if I don't talk? I just mark.
Okay.
Sorry, yeah. Okay, I'm let me drink some water. Yeah, 2 minus 14 is negative 12. Okay. Negative x bring down become positive x at the bottom. 4 bring over become 3 minus 4, which is negative 1 equals 0. Okay. Multiply throughout by the 3 power x. You get 3 power x square minus 3 power x. Then 3 power x cancel off. I left with negative 12. Good. Then let u equals to 3 power x. You get u square minus u minus 12 equals 0. Solve, you get 4 and negative 3 or negative 3. Yeah, then you just need to sub the u back with 3 power x. Then LG both sides. So we get LG4 over LG3. Good. Then this one, you log a negative, so you have to reject. It's undefined. Okay. Then LG4 over LG3. Let's just double check the value. LG4 on top, LG3 below. You get 1.26. Good. 3SF. And we're finally done. Yes. All perfect. Good. Yeah, nothing to go through. Okay, time to start a new topic. Wait a minute. Let me send you. Have I assigned all the logarithm worksheets to you already? Like all the I got send you all the files, right? Have I assigned everything as homework already? Did I go through everything? Oh, still got one more. I think you're already very good in logarithms already. You graduate already. Full marks already. Full marks logarithm. You know how to do it. I'm just gonna move on to new topic already. Is that okay?
Yay.
Okay, good. Let's move to a new topic. Your logarithms is very good already. Can next topic, what should I go to? I wanted to do the log. Okay, I prepared this already. Let me find the worksheet first. Sorry. Linear law, yeah. Okay, let me send you the files. And sorry, give me a moment. Find your name, find the folder, click and drag, send. Okay, I just sent you a bunch of files. It's the new topic. It's still on logarithms, application. Okay. Okay. Wait. Do you receive the files?
Yep.
Can good. Okay. Where did that folder go to? Okay. That's not it. Where did it go? Okay. 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 Okay, never mind. Just rewrite it manually. Okay. So 1.1, you see all the 1.1 lesson, 1.2 lesson, then HW1, HW2.
Yeah.
Yeah. So let's just start with the right. It's that file. Okay, 1.1. Yes. Look at lesson 1.1. So sorry. Let me download the folder also. Resume. Sure. Can you see the screen? Can see the smiley face? Can mic test. Can okay, good. Then I'll continue. Okay, so the idea behind this topic called linear law or the applications of a straight line is when you are trying to model, you need to know how science works, the traditional approach. So, like for example, you know the equation F equal ma. F equal ma. Yes, so whenever you have this kind of equation, right, how do you show that it is true? What you do is you need to collect data. You need to collect data. So let's say you have a bunch of data M and a bunch of data F. Somehow you can collect the data. Then what you need to do is to realize that, let's say, pretend that this A is equal to 2. Then if M is 1, F will be 2. If M is 2, then F will be 2 times 2, 4. 3, then it will become 6, so on and so forth. But in actual real life, when we are doing experiment, right, the data that we collect may not be so accurate. Maybe the M can be controlled precisely, but instead of getting actual data 2, 4, and 6, it could be 2.01, 3.9, then this one could be 6.01. It will have some sort of error. So what we do is let's pretend that we didn't know that A is equal to 2. Pretend that we didn't know that A is equal to 2. A equals to 2, question mark? We don't know. How do we figure out that A is equal to 2? We just draw a graph. M here, F here. Then we plot a bunch of points. 1, 2.01, plot a point. 2, 3.9, plot a point. 3, 6.01, plot a point. Then maybe eventually you will end up with maybe something like this. Then you have to draw a line of best fit. Draw a line of best fit. Then how do you determine the A? You can think of it as the gradient. Okay, this is like the gradient. Then by drawing the line of best fit, we can look at the gradient of this line of best fit. Then we can from there deduce the A. Does it make sense?
Yeah.
Kind of. Okay, but this is a very simple equation. And the reason, oh, sorry, can I just get my charger real quick? Hold on a second. Yeah, so this equation is simple because it is linear. What do I mean by linear? It means that it follows the format of y equal mx plus c, which you already know since sec 1. Sec 1. This is y. Sorry, wait, this is y. In this case, your gradient here is your a. Your variable here is your x. Can you see that? So and c is equal to 0 lah. So this is very nice because it follows y equal mx plus c format. and we want to make use of the y equals mx plus c format. But sometimes mathematicians or maybe physicists or scientists, they come up with some sort of equation to model the world, and it happens to follow certain formats. Like for example, let's say y equal ax n plus b, ax power n plus b. In that case, it's not very linear. If you try to plot a graph, let's say n equals to, I don't know, 2, so ax squared plus b, it will look something like this. Then we have to draw. Then if we collect our data, right, it will have some variation from the actual model. So if you try to draw a line of best fit, we need to draw a quadratic curve, which is a little bit difficult. Because there's many possibilities. You could bend a bit there, bend a bit there. So your curve of line of best fit will not be so nice. So that's why you try to flatten it sort of by converting it into a format that can be used by converting it into a format that resembles y equals mx plus c. But take note that the x and the y is capital X, capital Y, and it can contain any variables involving x and y. Okay, I don't use function notation. It could be anything involving x and y. So let me show you. Here in this case, if it's y equals a times x power n plus b, right, we want to flatten it. We want to make it such that it looks like this format, y equal mx plus c. How can we do so? One strategy is to take the ln on both sides. So we get ln y equals to ln of ax power n plus b. Okay, actually over here maybe there is a problem, which is that if you ln a sum, right, can you do anything?
No.
Cannot do anything. So maybe we shouldn't do that instead. What we do instead is to just it's already written here. Let x equals to x power n. Then we let y equals to little y. Straight away you will see this becomes y equals to mx plus c, where capital Y is equals to little y. Right, capital Y is equal to little y. Then capital X is equals to x power n. But what is your m, your gradient? It will be equals to a. What's your c? It's equals to b. The a here and b here. Okay, so for example, if let's say there was a scientist who's modeling a population growth of rabbits, and they happen to follow this equation, 0.01 x squared plus 2. Then we want to convert it into the capital Y equals to m capital X plus c format. What do? We just say let capital Y equals to a variable y. Let capital X equals to x squared. Then from there, we can rewrite the equation as capital Y equals to 0.01x plus 2. So now you know how the graph will look already. It will look something like this. Y-intercept here, the gradient is 0.01. But the x and y axis, do we still put small x and small y? No. Must change it into capital X, capital Y equals to little y equals to x squared. So on and so forth. So now in this lesson 1.1, I'm just going to show you some of the common functions and their corresponding capital X and Y. Can you give me 1 minute? I need to go and get something.
Okay.
Sorry, yep. Hello, I'm back. Okay, let's continue. So let's just continue with the next example now. If it's y equals a over x power n plus b, what do you think should be my capital X and what should be my capital Y? Let me give you a hint. This is a multiplied by 1 over x power n plus b.
Wait, are you?
Mic test. Mic test, can you hear me?
Are you writing something?
Oh, sorry. Oh, yes, I am. I forgot to resume. Sorry. Can you see? I give you a hint. A times 1 over x power n plus b. So what do you think is your big Y and your big X? It's our table. X equal. Exactly, yes. No. No. What A and B are constants. So just think of this like 0.01 and this plus 2. They're just numbers. We usually don't let a variable be a number. So it should just be Y. Okay. Does it make sense? Y and x power n. 1 over. Yeah, yes. So in that case, actually, you're not changing anything. Capital Y and little y is the same. Okay, next example. 1 over y equals to ax power n plus b. Yeah, correct. Yes. So 1 over y is your capital Y. Then x power n is your capital X. We just draw out the table. Okay. This one, next one. Ah, yes, correct. Okay, little y and n fruit of x. Okay, next one. Number 5. Go. Okay, I'm just going to, let me see. Me draw in a bunch of straight lines. Complete the table. Oops, let me make it straight. Like this, and then we need our capital X and our capital Y. Okay, what should it be? This one. Now you notice a problem. You got two terms here. You remember the format we want now. Y equals to mx plus c. Oh, wait, something important I forgot to mention. It is very important for you to know this format, and you must interpret this as, instead of just y equal mx plus c, interpret this as variable equals to constant multiplied by a variable times a variable. Then you add a constant. Okay, maybe it looks nicer if I write my variable at the bottom. Oh, so what my teacher used to teach me is variable equal constant times variable plus constant. Variable, constant, variable, constant. Alternating pattern. Oh, one term here contains variable. Second term here, just a pure constant. The problem over here in example 5 is that you got two terms. You see mx plus c, almost the same, right? But there's a problem. You see the plus c here, it's purely a constant. That's the requirement. But over here, we got b over square root x. The x here is a variable. So this is our problem. So what can we do? We can do some manipulation. We can multiply throughout both sides by square root x. So we end up with square root x multiplied by y equals to a times square root x times square root x, which is just an x, plus b over square root x times square root x, which is just a b. Well, big X can be little x, but y, it can actually be square root x times y. Yes, you can have a mixture of variables x and y. In case you are wondering. Capital X, capital Y. Oh, next one, x power. Yes, correct, because you can divide by x throughout. So a over x squared plus b. Yeah, so this is just a times 1 over x squared, which is x power negative 2. Or y can just be y. In this case, there is an alternative way to do it. There's an alternative way. Let me show you. We'll write it like this. An alternative way is to solve for y. Hey, no, sorry. Is to multiply by x squared throughout. Is it x squared? Let me double check. Sorry, multiply by x throughout. So what we get is x squared y equals to a over x times x, which is just a, plus bx squared. Do you see the pattern? Variable equals to constant times variable plus constant. Yeah, the pattern. Maybe if I rearrange it so it looks nicer, bx squared plus a. Then now you can see y equals to mx plus c. But the capital Y is x squared y. The capital X is x squared. So this is another way you could do it. Okay?
Okay.
Yeah, there's no one fixed answer. Usually there's quite a few ways. Yeah. Okay. Let me just, how do I keep this here? Maybe I'll put it at the bottom. Yeah. Okay. Let's take a look at question. This example 7 now. How? What should be my capital Y? What should be my small x? Capital X. Variable constant times variable plus constant. Y equal mx plus c. Good. Yeah. Can. Good. Let me just write that. Let me copy this now. X divided by y, you get bx plus a. Can. Another way. Let me show you another way. We can also divide by. We can also. Let me think a bit. Oh, this is a bit complicated. We can divide by xy throughout. That's another way, which is x over xy equals to bxy over xy plus ay over xy. Maybe I should draw a line to separate the working. This is totally separate. Then what do you get? X and x cancel off. X, y, y cancel off. Y, y cancel off. You're left with 1 over y equals to b plus a over x. So your big Y, sorry, if you recall, x is on the left and y is on the right. Maybe I should always write this down. So the capital Y is now 1 over y. The capital X is now 1 over x. Y equals m is a, then x is 1 over x, and the c is the b. Or if I write it more neatly, a times 1 over x. Y equals mx plus c. Okay? Yeah, so many different ways. This one is divide by y. Okay, next way, next equation. You got a over x plus b over y equal to n, or if you multiply both sides by xy, then you end up with ay plus bx equal to nxy. So who is the capital Y? Who is the capital X? You see, variable, constant. Variable, constant. Yes. B over y, good. Yeah, can. Good. Or you can just keep as 1 over x also, okay. Then the negative a will be the constant. Let me copy this down. B over y equals to minus a over x plus n. Then therefore your big Y will be b over y, then negative 1 over x. Yeah, can. Next one. Another not next one. Let's say another way to do this would be you can make y the subject. Okay. So how do you make y the subject? Oh, not y the subject, sorry. You cannot make it a subject yet. It's a bit too complicated if you try to make it a subject. What you can do is you can divide by n extra. a very, very crazy way. So ay over nx plus bx over nx equals to nxy over nx. Cancel off, cannot cancel off. So over here, what you notice is that you will end up with y on the right hand side. Then here you got b over n, which is just a constant over constant, plus a over n times y over x. So you got variable, constant. So you can rearrange it as y equals to a over n times y over x plus b over n. Then in that case, who's your variable? Who's your capital Y? Who's your capital X?
Oh,
Variable, constant. Variable, constant. Exactly. Yep. Y over X and Y. Okay, that's another way. Many different ways you can figure it out because you can have a mixture of X and Y's. Okay, next one. Y equal ax squared plus bx plus n. Okay, quadratic equation, right? How do you make it into a linear form? You look at the equation, must have two terms on the right side, one term on the left side. One term on the left side must always be a variable. Then after that, constant times variable plus constant. How? Okay, fine. You can also have your variable involve constants. What do I mean? Let's just move the n over. So you get y minus n equals to ax squared plus bx. What you realize is that here you got two terms already, but you still involve a variable, right? See, variable. What do you actually need? One variable, one constant. So what can you do? You see a bx here? It looks very close to a constant. Yes, divide by x. Okay. So divide by x, divide by x, divide by x. You end up with y minus n over x equals to ax plus b. Ax plus b. Yes. Left side is x, right side is y. So y minus n over x. Yep. So you can have a mixture of x and y's and n's constants for your capital Y and your capital X. Okay. Okay. Okay, moving on. Next example. So even more examples, 4 more. So let me make it straight so it looks nicer. So I can copy, draw a vertical line, and another one. What is my X? What is my Y? Good. So mx plus c, both sides still got variable. What can you do? 2abx looks almost like a constant. Divided by x. Yes. X equals to a square x square over x, and then plus 2abx over x. Anything to cancel? X cancel. X cancel. So you're left with a square x plus 2ab. This 2, the a, the b, as long as they are constants, it's fine. Yes, correct. The variable here is x, and the variable there is y minus b squared over x. Okay, good. Can next. How about y equal a over x minus b? Remember how many terms do we need? Right hand side, 2 separate terms. Here only one single fraction, one single term. Multiply. Then yeah, okay. So we can make yx the subject, then we get yb, or maybe if I rewrite it as by plus a, right? Yb and by is the same. Minus bring over become plus. So this is y equal mx plus c. So y equals to yx, b equals to y. Of course, you can also swap them around equivalently. You can also get like minus by equals to minus yx plus a. Then in this case, this will be capital Y equals to hold on. No, that doesn't work. Cannot. There's no m here, right? What's the m? Actually have there's a negative one. There's a negative one. So mx plus c, where y is negative by, m equals to negative 1, x equals to yx, and c equals to a. Actually, you don't even need a negative 1. You can just keep it as 1. Do you know? Yeah, you can just keep m as 1, then your capital X can be your negative yx. Okay, that's another way, but whatever. There's many different ways. Just think of one that works. Okay, now we got a product going on. You actually need a sum. What should you do? How? Question 12. Product to sum. Product to sum. We got times, you want to turn into plus. Logarithm, exactly, yes. I use my favorite ln. I get ln ax plus ax power b, which is ln of a plus ln of x power b. But the power can bring down. So you are left with b ln x plus ln a. Can you see the y equal mx plus c pattern? Y equals mx plus c. Yeah. So capital Y, this is x, that is y. Your capital Y is what? Capital X. Ln x, yes. Okay, next one. Oh no, there's a plus n. Can we take the ln straight away when there's a sum? No, so what should we do? Bring over first. So we get y minus n equals to ax power b. Then what do we do? What should we do? A mic test, I can't hear. Sorry, you message me or something?
No.
No. Okay. Yeah, what can we do? Actually, let me see. There is another way. Sorry. Let me share the other way for the part 12. Part 12. Sorry. Actually, there's a simpler way to part 12. It's just plus or 0, right? That's it's all plus 0. So isn't it just y equal mx plus c straight away? So the capital Y is little y. The capital X is x power b. M is a, c is 0. So how about over here? Yeah, exactly. X power b or y and y. Okay, that is one way. That is one way, but you can still take the logarithm. It also works. Maybe I should write down both ways. Well, I need more space. Hold on a second. Let me just maybe else. Let me clean up everything. Wanna have a neat summary for you, so you can just reference to it if you need to. Then the top one you can actually just leave as is. Just think of it as plus 0. So you get a capital X being x power b and the y being just y, capital Y being y. Then this other number 13 will also be the same pattern. You just leave your capital Y as little y, capital X as x power b. An alternative would be to take the logarithm, then you get ln of y. Okay, sorry. You bring the n over, so y minus n, then you take the ln of y minus n, which is ln of ax power b, which will become ln of a plus ln of x power b, bring down the power, b times ln x. So x in this case will be ln x, then the y in this case will be ln of y minus n. Right? Y equals to mx plus c. Okay, next one, last one. Now, previously we had a variable to the power. Now it's variable to a constant. Now it's the other way around, constant to a variable power. What would it be? Your x and y. Can. Let's say ln y equals to. Yeah, good. So, correct. Yeah, x and ln y. Okay, good. Another way is to just leave it as is. As is, just leave it alone. So the variable y, capital Y will be little y, variable x will be b power x. Also okay. All right. So now that you have learned how to linearize a function, convert it into a linear form, we can, still got 3 more. Okay, let's just finish up this example. For number 15, how would it work? You just take LG on both sides. LG y power n equals to LG b power x over a, which is LG b then power x to bring down the x, then minus away LG of a. So what's my x and what's my y? Oh, wrong. Should be capital X, capital Y. Capital Y. What would it be? Here, you can just take LG y power n. Then you see there's a variable x. You can just take the x. So it becomes y equals to mx plus c. Can you see the pattern? Alternatively, there's a power n you can bring down. So it's n times LGY. Then you can divide by n throughout. So over n over n. Then you take LGY as the what do you call it, variable y. Let me just copy down because I'm running out of space. Another way that you could have done this is to leave this alone, and then you can have n times LGY. Then you make LGY the subject by dividing by n. So you get x multiplied by LGB over n minus away LGA over n. In that case, you'll end up with y equals to mx plus c. The x being the variable x, the c being minus LGA over n, the m being LGB over n. Can also, this also works. Okay, then let's just finish up the last three. You got 16, y times a power x equal b plus n. What should you do? Constant plus constant, constant is just constant. So this is just one constant k. Then you have a product on the left side. What should you do? Product multiply must turn into a sum using log. That's why this topic comes after logarithms. just log everything. X and on Y. Yeah. Maybe can rearrange it as this ln A minus ln A times X plus ln B plus N. Yeah, let's just finish up the last two. So what should you do? Here you got base 10. So instead of taking ln, maybe you should take lg this time. So lg y power b, b can bring down, you get b times lgy equals to lg base 10 of 10 power 2x plus a. They will cancel each other off, you become 2x plus a. Yeah, x and lgy. Here in this case, you cannot be just lgy anymore. Because you see, y equal mx plus c, the coefficient of y is 1. So it must become b times lgy. Yeah. Or you could divide by b. Then you will transfer over to the m and the c. Yeah. So next one will be, yeah, should take ln because there's a base e. Maybe I should underline this. Use log base e ln. This one base 10 means you should use lg log base 10. Okay, then you end up with b times ln y equals to 2x plus a. Yeah, b ln y, yes. And x. Okay, good. Can homework, right? What else? Let me go to the homework. Hold on a second. Let me share the screen. Oh, are you typing something? Oh, okay. Okay, no. Can see? Okay, so let me just go through some of the homework questions. It's not resuming. Oh, okay. Can you see the share screen? Can I hope so. Is it getting too late? Then you cannot make too much noise. Or something. I'm not sure. Am I still connected? Sorry.
Yeah.
Yes, okay, can. Yeah, so let's take a look at this number linear law homework. So for question 1, what are we gonna do? This is actually not linear law yet. This is just the exponential application. Just give some extra examples about bacterial growth. You got an equation. Then they tell you initial is 17. So what is the value of n0? It's just 17. So nt equal to 0, solve for n. We already did this, question 1 and question 2. We did something similar already, lots of practice. Then 3 and 4 right, is 3, 4, 5, and 3, 4, and 5 is actually a recap on what's that? The discriminant b squared minus 4ac more than 0 equals 0 less than 0. Oh, just a recap, and as well as a bit of coordinate geometry. Have you learned equation of a circle?
No.
Okay, that's no good. Okay, never mind. Then you skip 3, 4, and 5. Skip 3, 4, and 5. Okay.
Nice.
Then for 6 and 7, maybe you can try it first. They'll try to understand what they're trying to say. When they say a graph of y over x is plotted against x, it means that your vertical y-axis, capital Y, is y over x. Your capital X is little x. But it's from this equation. So what do you need to do? Yeah, then you need to think about it. How do you get a y over x from y? Divide by x, so on and so forth. Then we already went through like 15 different examples on how to do that, convert into the y equal mx plus c. Then they tell you the resulting line, which is the capital Y equal to m capital X plus c, will have a gradient of 5 and an intercept of 0.25, which means your little m, your little c will become 5 and 0.25 respectively. Then from there, you have to solve for A and solve for B. You can go think about it. And question 7 is the same question. I just changed the numbers. Okay, can. That's all for today. Maybe I'll assign more homework later. Can. Thanks.
Okay.
That's all. Bye-bye.
Thanks.
Thank you. Bye-bye.